Let's see how to solve this problem. Cheat code number 207, course schedule. Let's read the question. The question is, there are a total of num courses you have to take labeled from 0 to num courses minus 1. You are given an area of, we have courses actually, they're saying, you have these many courses, and these are labeled from uh, 0 to num courses minus 1. You are given an area of prerequisites, where prerequisites of I, which is an array AIBA, indicate that you must take course B first if you want to take course A. So we're given prerequisites means some before things where each prerequisites contain A and B, which means the same the first. So if you want to complete A, B must be completed first. After completing B only, then you can do complete A the same. For example, here we have 0 and 1. In the case that to take course 0, you have to first take course 1. So after taking course B only, you can take course C. So they are asking return true if you can finish all the courses, otherwise return false. So we just need to return true or false according to whether we can complete all the courses or not. If we can complete all the courses, we should return true. If not, we should return false. Let's see an example here. So first example is we're given two courses which are 0 to 0 and 1. Prerequisite is 1 comma 0. Okay, which means I should complete 0 and I should complete 1 next. I should take course 0 first, then course 1. So there are no issues here. I can take course 0, after that I can take course 1. Okay, so this is true. I can complete it. Let's say example 2. What is example 2? So again I have two courses, 0 and 1. First one is saying I have these prerequisites 1 0 and 0 1. That means first prerequisite is saying you need to complete 0 first, and you take course 0 first, then 1. And second is saying I should take 1 first, then 0. So if you observe, if you bring this way. Hmm. So, okay. I have a I have an edge from 0 to 1 and 1 to 0. It's like a cycle, to be more precise. 1 to 0 and 0 to 1. So if I need to take course 1, I need to complete 0. If I need to complete 0, I need to take course 1. Here if you can see, it became a cycle. To complete this, I need to complete this. Complete course 0, I need to complete course 1. So which is not possible. Here it will be false. So this question boils down to simple algorithm, where they are asking if there is a cycle, return false, because we can't take courses. If there is no cycle, return true. Let's see how can we do this. And it is a dielectric graph. Okay. Let's see how can we solve this using DFS, depth first search. Basically, we need to return whether there is a cycle or not. If there is a cycle, return false. If there is no cycle, return true. Okay. So I'll take M as num courses. I need an adjacency list. Memory list. Current I0, I less than I plus plus. Add up new array list. So let's take the edges, prerequisites. So into ef0 into f1. I have an edge from V to E, okay, to U. So edge essentially start get of V dot add U. So with this I'm able to form my edge sensitivity cycle. There is cycle return false. Else return true. So let me true or false. Okay. So I need to check in this adjacency list 10 nodes. Do I have cycle or not? How can I check this? Let's see how can we check cycle in an diametric graph. Let's take an example. 0 to this is just P2. I mean, of arrow. Can't see it anywhere. There I have like this, and here also I have an edge here. It is able to keep arrow downside. I couldn't find any. What shall we do? Let's take this thing. So, basically 0 to 1, 1 to 2, so 1 to 2, 2 to 3, 3 to 0. I have a cycle here. Okay, you can observe this is a direct graph and there is a cycle from 0 to 3. So how can we detect it? I'll take two things. One is visited array which we need. So our nodes are initially all are 0, nothing is visited. Let's see path. Let's fill the path. Okay. Whether I'll tell you about this. The nodes were 0, 1, 3. Okay. What I'll do is when I visit any nodes, the first time I'll mark it as visited. What does my path will say is if I am currently moving from one node to another node, what are the nodes I have visited in my path? If I go back, I'll remove that in my path. You'll see when I explain it. Okay. Okay. Let's start from 0. 0th node. First mark it as visited, and I'll tick it in my path. I'll see its neighbors. Its neighbor is only 1. I'll come to 1. Is it visited? No, it is not visited. I'll mark it as visited. I'll tick it in my path. and I'll see one address which is 2. Is 2 visited? No, it is not visited. I have marked as visited and I'll add it in my path. Then come to 3. Is 3 visited? No, it is not visited. And I'll come here and add it in my path. And I'll see neighbors of 3. Neighbors of 3 is 0. Is 0 visited? It is visited. If it is visited, no issues. But the problem is it is still in my path. I started from 0 and again I came to 0. I visited and it is in my path, current path, which means I'm able to come here because there is a cycle. Because of that I started here and again I came to here. So if hence I will return true. Okay. Now let's write code for this. What do we need? We need a visited array. Path. There can be many components. For I0, LSN, I++. It's current node is not visited. Not visitable. I call DFS. If it returns a cycle, I'll return it. Return 2. Even if I found one cycle, else I'll return false. Okay. For DFS, what is my current node? My visited array, my path, adjacency list, and number of nodes. This is good enough. Let's write code for DFS. Boolean DFS node Boolean visited Boolean path and adjacency list. People to side and number of nodes. Okay. First one, I need to mark a current node I visited, and need to mark it in path also. Path of node equal to 2. So now I'll check its neighbors. In neighbors of adjacency list of data from current node. Let's see. If it is not visited, then no issues. Okay, I'll write logic for it. If it is visited and also it is true, it is in my path, then I return to I found my cycle. So to do DFS are neighbor, visited, path, adjacency list. If I got any one cycle, I return to. I don't need to go further. So that's it. So I got an error. So it is expected to, but I returned false. Okay. So I'm returning false when there is cycle. But in case of 1 0, there is no cycle. What I'm missing. Let's see. Adjacency list will be 0 contains only 1. 0 to 1. Okay. 0 visited. It is not visited. Come here. Mark 0 is visited. Mark it in path. Welcome to its neighbors. Its neighbor is only 1. 1 is node is not visited. I'll do DFS on it. I'll mark it in my path and I check the neighbors of 1. There are nothing. I'll remove it and I'll return false. 0 is 1 and I'm returning false. This will return false. So if it is returning false, I'll come here and I'll return false. I'm returning false. And something is wrong. Hmm. So instead of neighbor, I have written node here. Okay, let's see how. Hmm. So I'll remove this. Let's submit. So got one wrong answer. Okay. Let's print existing cells whether it is correct or not. Two nodes and it is as expected. It should be neighbor. And now it is open. Yeah, now it will be accepted. So just some mistake. Instead of neighbor, I have written node here. Let's submit this. It got accepted. Now let's analyze time and space complexity. So time. So what I'm doing, I'm forming my existence list. You can calculate time for this also. Right now I'm ignoring this. Mm, right for this one. This is big of n and DFS. It will be big of n. Right time here. N is number of nodes here. DFS will big of since it is a directed of space. Mm, yes, I'm ignoring again existence list. If you want, you can add it. So this is visited path and recursive stack space. This is for visited path and recursive stack space. So this is the time and space complexity. So yeah, that's it. Thank you.